Good morning, everyone. I welcome you all for this new episode on WBC hemocytometers, which is a spotter in transfusion medicine, in hematology, in laboratory medicine. You will come across this hemocytometer somewhere or the other, and it is a very simple spotter, but you need to master it, and that's how you're going to, score the point in these spotters. So today we'll be talking about both the improved Neubauer chamber and the Nageotte chamber. My name is Dr. Mohit Chaudhary, and I am accompanied with my colleague Dr. Rashmi Jain, and we'll be taking you through this spotter that is a hemocytometer, Neubauer chamber, and Nageotte chamber. To start with the proceedings, I would like to call upon Dr. Rashmi Jain, who will be discussing improved Neubauer chamber today.
I will be talking about the improved Neubauer chamber. As we all can see, it is available as a thick glass slide having the H-shaped gutter which divides into two counting areas. As we all can appreciate over here, these are the two counting areas, 1 and 2. The purpose of this chamber is to count the number of cells, that is the red blood cells, white blood cells and platelets available in the biological fluids. Now, it's important that we understand the design of the improved Neubauer's chamber. This Neubauer's chamber is available as a 3 into 3 mm grid. Each and this 3 into 3 mm grid, which is being further divided into 9 squares by the horizontal and the vertical lines measuring 1 into 1 mm square. Each 9 squares, as we all can appreciate, are further divided into 16 squares respectively, and the center one, which is used for counting the red blood cells, is being divided into 25 squares. Here, the cornermost squares are being used for counting the white blood cells as being denoted here by the W, and the centermost square is being counted for counting the red blood cells respectively. Now, how do we count the white blood cells? The commonly used diluent is the Turk's fluid. The composition of the Turk's fluid is glacial acetic acid 2 ml, gentian violet 1 ml. The purpose of glacial acetic acid is to cause the lysis of the red blood cells. And the dilution factor, which commonly we take into account, is the 20. So, now, counting the white blood cells. For that, we are going to use the four cornermost squares, that is 1, 2, 3, 4. Using the L technique, we are going to count the cells into these squares. So, let us assume that all the total number of cells counted in the squares are n. So the formula which becomes is n into volume by dilution factor. So the volume is being calculated as follow: area into the depth. So it comes out to be n by which comes out to be n by 4 mm into the 0.1 mm, 1 mm, and multiplied with the dilution factor, that is 20 as mentioned before. Therefore, white blood cell count is equal to n into 50. Now, for the calculation of the red blood cell, as I have previously mentioned, we are going to count it in the centermost square. For that, and even in the centermost square, we are going to consider the cornermost small squares and the most central tiny square, that makes into 5 squares. So in this, the dilution factor which we use is 200, and the diluent which we commonly use is the Himes fluid, which consists, the composition of the fluid is sodium chloride, sodium sulfate and mercuric chloride respectively. So after this, let us assume that the total number of counted cells in all the 5 stated squares to be n. Therefore, using the same formula, n by volume into the dilution factor, we get n by 1 by 50 into 200. Therefore, we can calculate the RBC count with the simplest formula, that is n into 10,000. Now coming to the calculation of the platelets. The diluent that we used commonly here is the 1.8 ml of 1% of ammonium oxalate, and the dilution factor being considered is the 100. The platelets we are going to count in the centermost 25 squares. Okay, using the similar formula, that is N by volume into the dilution factor, we will calculate the platelet count. That comes out to be N by 25,000. I hope I was able to explain it in a brief and crisp manner. Now, my colleague Dr. Mohit Chaudhary will be talking about the second most commonly asked spotter, that is the Nagetti's chamber.
Thank you, Dr. Rashmi. Now let's come to Nageotte chambers. So this is a simple looking hemocytometer. You can see it's a thick glass slide having H-shaped moat which divides it into two counting chambers. So this is one counting area and this is the second counting area. It is basically done to manually count low leukocyte concentration below the capabilities of the standard hemocytometer. So it's a modified hemocytometer and it's called a Nageotte chamber. Now the grid, the Nageotte chamber grid, you can see it's a 10 by 10 millimeter square. So this is 10 millimeter and this is another 10 millimeter square, 10 millimeter, and you can see it is divided into four parts. So each part has 10 rectangles. This is 10 rectangle, another 10, another 10, and another 10. So it is actually 2.5 millimeter uh, area, which is 4 times, which is 10 millimeter. So you can see that the counting area have 40 rectangular square, each having a vertical spacing or of 0.25 mm. So this is 0.25 mm into 10, which is 2.5 millimeter. So another 2.5, another 2.5, another 2.5. So total we have these 40 rectangular areas. So this will be the counting chamber grid. So each 40 rectangles are in a set of 10, each separated by a 0.01 millimeter vertical spacing. The depth of the chamber is 0.5 millimeter. So when you calculate the volume of the grid, if you suppose you have to calculate the volume for this part, that is 1 by 4th of the grid, what you do is you multiply 2.5, that is area into depth. 2.5 into 10 will give you an area that is 25 millimeter into 0.5 millimeter, which will be 12.5 millimeter cube. So this is 12.5 millimeter cube will be the volume for this part. Another 12.5, 12.5 and 12.5. So total we have around 50 microliter or 50 millimeter cube will be the total volume. So once you have the volume, you can further calculate the WBC. The diluent that you can use is any WBC diluting fluid. You can use Turk's fluid also. That dilution factor we have kept it the same like we used in improved Neubauer chamber calculation, which is 20. So suppose we have to calculate the total number of leukocyte count, which is N. So the volume of the grid will be 50 microliter. We have already ascertained that. Depth is 0.5 millimeter. So cell count is very simple, 2n by 5, that is n into dilution factor upon volume. So to further total to actually calculate what is the leukoreduction or what is the actual WBC count after leukoreduction, you need to know the volume of the component. So what you do is you have the cell count which is there now, you multiply it by 1000 microliter because you need to convert it into microliters per ml, and then you multiply with the volume of the component. So this will give you the calculation of WBC, the WBC which are left, or the leukoreduced, how well is your leukoreduction. So once you have that, you can calculate the WBC, remaining WBC, and you can see how much log it is leukoreduced from the start. Suppose you had 10 raised to power 9 and it is now 10 raised to power 6. So that means it is 3 log leukoreduced or more. So this is how a Nageotte chamber you can calculate, and I hope now we are able to actually perform the calculations for both improved Neubauer chamber and Nageotte chamber. Improved Neubauer chamber, we all know how why it's called improved Neubauer chamber. It's because of the grid that are different from the previous Neubauer chamber, in which the central square had only 16 squares. Now it is 25. That is the only difference between the Neubauer chamber and the improved Neubauer chamber. So this can also be a Viva question. So what is the difference between Neubauer and improved Neubauer chamber? And between the improved Neubauer chamber and Nageotte chamber, it is generally the hemocytometer which has been, modified or programmed in such a way that we can calculate very low content of WBC which is remaining, especially in the transfusion medicine when you have to, manually see how much leukoreduction you have done. So thank you so much. If there are any questions, please let us know. Continue subscribing our channel and do like this video if you like it. Thank you so much.